Okay, so what we're looking at in this video is creating the crank arm. And as you watch the video, what you'll need to do is have a printout of the crank arm drawing is best, or a separate screen open with a PDF of the drawing. We'll talk about the dimensions that are in that drawing, and you're actually going to find those at the bottom of the drawing in a table. Okay, you'll see down there there's two different measuring types. One's metric and the other is imperial, and we will be working in metric for this video. We're just going to start a new Inventor part file, so we're going to click new, and we are going to use the metric folder, and we want to use this template here, standard millimeters. We'll click create, and we'll wait for that to load. Okay, so to start this part off, you're going to start off with a sketch, as we always do. And this sketch is kind of going to sit, if you can imagine slicing the part in half, kind of through the middle of that plate. You'll see three cylinders. One's really large, it's in the middle, and two kind of off to the side. And then there's a plate that connects them. So if we slice that plate in half, that's where our sketch is going to sit. Our sketch will start with the big cylinder first. So we're going to start with a circle, and we're going to start it right at the origin point. And if we look at our drawing, we can see that dimension B will be 60 millimeters. So we'll type that in, and I'm going to double click my mouse just to zoom out and see everything. And following that, we can start drawing either circles or lines. And I think for my workflow, it's going to work easier if I do a line. I'm going to start it right at the origin. And this is going to be my line out to the circle on the right of the part. If you're looking at the top view, that circle that is a diameter D. Now the length of this line is actually A. This is dimension A. You'll see it on the drawing. We see that dimension A is 96 millimeters. So we'll type that in, and we'll double click so we can kind of zoom out a bit. And now we're ready to draw this circle out here on the right. So we'll just go right from the end of the line. We're going to make a circle that is dimension D, which is 36 millimeters. We type that in, okay? Next, we're going to do the circle on the left. And before we do that, we're going to do something similar to the previous circle in that we're going to start it out as a line. This is dimension A as well. It's 96. Just kind of set it at an angle. I didn't try to be too precise about it. I'm going to come and fix that up now. So if we look at the drawing of the crank arm, we can see that the angle of this line should be 30 degrees from the horizontal line. So we can tell it that. We can go to the dimension tool, and we'll click both lines. We're going to pull out a dimension. We can see here that what we drew was 23.9 degrees, and we're just going to fix that up to 30. The length of the line doesn't change, that stays. And now we can draw our circle. Circle is going to start at the end of the line. It's going to be a 36 millimeter diameter circle. And we are done for now. So we're going to go back to lines. We're going to create all the lines that go and kind of join these circles together. So to start, I'm just going to start anywhere on my circle. It doesn't matter too much. I can come and fix this later. And I want to go up to this middle circle. You'll see a little symbol popped up just above where my cursor is. It's a tangent, indicates a tangent constraint. We'll talk more about that as we go. I'm going to click there. I'm going to do another line over here, starting somewhere on the circle and coming over to this circle. And we'll do the same thing down here. Okay, I'm just kind of letting the line snap to the circle somewhere. I don't care yet where it is, as long as it is right on the circle itself. Okay, right on the outline of the circle. What I want, and I mentioned it earlier, is I want this tangent constraint wherever the straight line meets a circle. Okay, so I have it in one spot, but I need to add it everywhere else. So I'm going to click this. This is your tangent constraint. You're going to click the line and the circle. Okay, You'll do the same thing here, and we've got two more spots. One's here, and the next is here. And we might have missed this one here. We'll do that. You'll notice that once we applied that constraint, all of the lines in the drawing became black, which indicates that they're fully dimensioned or fully constrained. Okay, so we're going to hit escape on the keyboard just to get out of that tangent thing we were doing. And now we're ready to do our first extrusion. And for our first extrusion, what we'll do is we'll first finish our sketch. We'll zoom out, and we're going to click the extrude button. And we're going to come here, and we're going to make everything that is what I've been referring to as the plate of the drawing. You see how it's projecting above the sketch we did, which is okay, but like I mentioned before, I want my sketch to kind of sit in the middle of this plate, this whole part. If we were to slice this part in half, the sketch will be in the middle. So what that means is we're going to do a different kind of extrusion. We're going to do where you see where my mouse is, we're going to do something called symmetric. So I'm going to click that button. You'll now see that the sketch is here, and it's extruding both to the top and to the bottom of that sketch. Now we need to tell it the distance of the extrusion. The distance of the extrusion is H on our drawing, which is 18. And, okay. All right, so what you had happen here was we got the plate we wanted, but we kind of lost our sketch. It disappeared. It's similar to what goes on with the wrench. If we recall when we did the wrench, what we need to do is we need to click on the sketch. We need to right click with our mouse, and we need to keep it visible. So we turned on visibility. Now we've got something we can work with, and we're going to start extruding cylinders. Okay, so we're going to start with the big one. And if I zoom in and pan around, we can see it a little better. I'm going to click both parts of that. And this one, instead of being just a symmetric extrusion, if you look at the drawing that's provided for the part, you can see that the top part of this cylinder that projects above the plate is a lot longer than the bottom part of the cylinder. So we're going to do this here. It lets us enter two different extrusion values. So distance A, we're here, and we can see that this copper colored arrow is showing which direction distance A is. We can see that's up from the center of our part. So we need to do a little bit of math here. When we look at our drawing of the part, we can see that we need to go up G, okay? But we also need to go up half of H. Remember, our sketch sits kind of in the center of the part as if we'd slice the part in half. So we need our distance that we extrude up to be G plus half of H, which if we add it up will be 48 millimeters. So we'll enter that in. And now distance B, you can see the copper colored arrow came up here, is the distance that we're going to extrude down. Okay. I'm looking at my drawing again. I can see that's going to be half of H. I know that. And now I'm looking for dimensions. I can see I and J. So if I add I, which is 12, to J, which is 3, plus half of H, which is 18, that is the distance I want to extrude down. If we do the math, we find out that that's 24 millimeters. So we're going to type that in for distance B. Now it's a matter of extruding these two outboard cylinders, and we're just going to simply do an extrusion. We're going to come in here. I'm going to select this one and this one. These are both the same. They both go the same distance from the center point of our plate. So we're going to do a symmetric, back to symmetric here. We were in asymmetric, now we're back to symmetric. And if we look at the drawing, we can see that E is the distance we're going to extrude. E is 24 millimeters. So we can do that now, and we'll click OK. And there we go. That's kind of roughly the shape. Now there's a couple things we need to add. We need to add a bore, a hole that goes all the way through the part, and then there's a counter bore. The counter bore, if you look at the drawing, you can see a dimension C, a diameter C. That's what our counter bore is going to be, and we're going to have to draw it on this face on the top. And if we look at our drawing, we can see that there's one on the bottom face as well. So we'll do that now. It's going to end up being two separate extrusions, one from the bottom and one from the top, okay? So what that means is we're starting a new sketch, starting it here on the top face. I'm going to do a circle, and it will be diameter C, which is 48 millimeters. And on the top, and leave it there. Okay, so we're going to finish that. We're going to extrude it down. Okay. We are not adding material to the part like it wants to do by default. We're going to cut into the parts. We're going to come over here for our Boolean operation. I'm going to say this is going to be a cut into the part. What is the depth of our cut? Well, we look and we see that it's I on our drawing, which is 12. Okay. And we will now follow the same process on the bottom of the part. So click on that face, and we'll draw a circle. Okay, again, it's diameter C, which is 48. Extrude this face into the part as a cut. Distance already 12, we can click OK. Now, we're going to do these two outside circles, and we can maybe even do this inside bore. What we'll do is we'll do the two outside circles as one sketch, and then we'll come back and do this inside bore, this central bore. And bore, by the way, means hole. We'll do the central bore as another new sketch. So I'm going to start a new sketch on this face. It is a circle. And if we look at our drawing, that's diameter E, which is 24 millimeters. Okay. Same thing over here, 24 millimeters on the keyboard. Hitting enter and finishing the sketch. Finally, we're going to come in and we're going to do these both at the same time as cuts. And instead of going a set distance of 12, we want to go all the way through the part. So we're going to say through all, and we're going to click OK. One more central bore to take care of. Start off as a new sketch on this face, and we will again draw a circle, and it will be diameter D, which if we look at the table is 36 millimeters. Okay. Sketch and extrude that as a cut all the way through the part. So cut and through all, and click OK. Your part's mostly done. We've got this sketch showing, which we don't really need anymore. So we're just going to click on that and turn off the visibility. If you look at the drawing you were provided, you'll see that in this area here where this green edge is, this inside corner, and over here at this inside corner, and if we zoom in, this inside corner, all have kind of a rounded profile, okay? And your drawing has a note, it says rounds and fillets RJ. That RJ means radius J. If we look down at our table, we'll see what J is, that it is 3 millimeters. So what this is telling us is we're going to put fillets on these inside corners that are a radius of 3 millimeters. So we pull up the fillet tool, and we tell it that the radius is 3 millimeters. Now all we have to do is pick our inside corners. Okay, we're going to start with the middle one. We're going to click on this one, and now we need to do something similar on the bottom side of the part. So just get this oriented. We can zoom in. We can tell it that, and we're going to pan over and orbit in. And now we can zoom in and we can say right here we want to fill it as well. So we just click OK. Your part is looking pretty good. To get this across the finish line, what you're going to do is you're going to tell it what type of material this is. Okay. On the drawing you're provided, again, there's a note. It says material cast iron. All right, so that's telling us this is a part. It's actually made out of cast iron. So we're going to go here to where it says generic. We're going to click this drop down arrow. It's going to give us a list of different potential materials. Okay, so there's quite a few options, and we are going to look for the iron option. There we see iron. You've got cast, ductile, and gray. Malleable as well. We know we want cast iron, so we're going to say iron cast, and it's automatically applied that to the part. Okay. If you want to get fancy, come over here to the menu beside the material menu, and there is a nice option for cast iron. Okay. If you click iron cast, it gives it that kind of dimpled appearance that cast iron typically has. So that's your part. We're going to save that as crank arm. You can do that on your own. That concludes the video. Thanks for watching.